And here in the voice setup, we are going to configure the tuning of Cohen-Coon as you see here after the interruptions. Even here I placed the 3 tunings for you to select the one you want. Here is then the P tuning. It would be enough to uncomment these 2 lines where we are the proportional parameter and the T and TD at 0. If you want the PI control, which is the middle one, uncomment these 3 lines again. We also see the proportional parameter, integral and derivative at 0. And for this case, in our example, we will implement the PID control with the 3 parameters of the last row of our tuning. They know that these parameters, KP, TI, and TD, are then transformed here to the digital PID controller. Let's remember that, here at the delay, we are making the correction at the beginning because this is designed for continuous controls, and we must make this correction for discrete controllers, like what we are doing here in Arduino. They currently have the task of applying the controller, the PI, using the Cohen-Coon method as their homework. Your task is to examine and analyze the dynamics and response of the temperature lab using that PI tuning. Please provide your findings and insights. And that is the task they have assigned for this video.
If you want to learn how to program this control algorithm, I've got something special for you. I've created a Udemy course focused on teaching you how to program and apply different control algorithms directly on Arduino. This course is designed to take you from the basics all the way to advanced applications using practical examples in real-world scenarios. Simple, click on this card or the link in the video description to enroll in the course at special discount. This discount is only available through these links, so you won't find it if you search directly on Udemy. You'll have lifetime access to the course and can progress at your own pace. You can ask me any question about covered topics and I will always be here to answer them. At the end of the course, you will earn a certificate of completion. So, I hope to see you in the course.
Absolutely not. There is no way that is going to happen. The control ASCs for Cohen-Coon managed to reach the reference as we just saw. At this moment, since we are at the reference, we proceed to apply a disturbance of the impulse type to ventilate. So, at this moment, look at the transistors to cool down the temperature a bit, and let's see how this PID controller behaves in the presence of disturbances. The disturbance was completely rejected at this moment. We are going to implement a step change in a descending manner in this particular situation because it is descending in a practical sense. Our controller is going to take a slightly longer time. As we have already explained previously, the Cohen-Coon proportional integral derivative PID controller performed flawlessly in this case. We proceed here to save the database of the experiment we just did with this controller of our Arduino so that you can reproduce it, and your task is to analyze what the dynamics of a PI will be and compare it with this response that we have obtained from the PID control, which is quite good, so I highly recommend this tuning.
If you are interested in seeing the code and learning more about implementing controllers in real life using microcontrollers like Arduino, I invite you to enroll in the course. Click here to access the discount. Also, check out our playlist for more insights. I look forward to seeing you in the course. Take care and see you later.